Right, welcome back. I hope you're enjoying yourself so far. Our next speaker is Srujana Kaddevarmuth. She is a Senior Director, Data Science and Value Creation at Walmart Global Technology. Please join me in welcoming her to our virtual stage.
Hello, everyone. My name is Srujana Kaddevarmuth. I lead the Charter of Data Science and Value Creation as part of Walmart Global Tech. I'm responsible for leading the technology teams to drive enterprise scale value and build data science solutions specifically around platform research and creating commercial grade data science products to drive enterprise scale value. Today, I'm going to be talking about productizing data science to create business value. This topic is novel and interesting, not just within Walmart, and it has got a huge relevance across the industry, primarily because many large organizations like Walmart, which have got humongous amount of heterogeneous, non-intuitive data, are in the process of democratizing their data with the intent to drive greater business value, automate business processes, expedite business decision-making, achieve human capital efficiency, and foster innovation. So over the next few minutes, we'll be talking about what is data science productization, what are its benefits, some of the risks and unintended consequences. We'll explore avenues to mitigate these risks and also look at the overall value creation roadmap. We'll close by understanding how AI revolution is happening and how can we encash this momentum to drive a greater sustainable value for our enterprises. Before we get started with the topic, let me give you a brief context about Walmart so that we can appreciate the scale and complexity when we discuss the use cases later. Walmart is a Fortune 1 company which has long led the innovation and digital transformation, specifically in the retail sector, to create a great shopping experience for all our customers and empowering around 2.2 million associates globally. Walmart Global Tech is a technology arm of Walmart responsible for building technological innovations to create an excellent shopping experience for our 220 million customers across the globe, across Walmart, Sam's Club, and Walmart International, providing some offerings such as grocery online delivery and pickup, as well as Walmart Pay, express delivery, so on and so forth. Whatever we build at Walmart is specifically at scale and is used to drive enterprise value by leverage and reuse. For example, the technologies that we are piloting at the distribution centers at California can be leveraged and reused across South Africa. We use technologies like artificial intelligence, virtual reality, Internet of Things, and blockchain specifically to create faster and more efficient businesses. And this is primarily achieved through some of the core and fundamental concepts such as data science productization. So what is data science productization? It's a process of generating insights, and it's a journey of translating these insights generated from the exploratory analysis to scalable models that can power products. It involves nuances of building the models and deploying them in the production environment effectively and efficiently. As I mentioned, that it is a process and journey, and this journey begins with the first step of identifying the right business opportunity. We look at identifying the right business opportunity not just by looking at how strategic it is for the business and how much the business needs it, but also by bringing in the financial angle to that. We look at bringing in financial rigor for all the opportunities that we scope to look at how much value is at stake if we don't build a solution, and if we build a solution, what amount of incremental revenue or net income we'll be able to generate. From my experience, the pull model works very well here as against the push model. That is, the solutions that are developed based on the business need works much better as compared to the solutions that are developed just based on the research acumen and pushed across to the business to drive greater adoption. The second step is about insight generation. And this involves building proof of concepts and MVPs. MVP release in this case is very important because it helps us determine whether these products are sustainable in the long run or not. It also helps us put in an effective monitoring framework in place. And during the MVP phase, if we realize that these solutions are creating and generating positive impact, then we move on to the next phase of scaling and automating these solutions. And this is where we give a lot of emphasis to the technology stack, to the architectural design for achieving computational efficiency. If the organization operates across different channels like Walmart, then we make sure that the solutions that we are building and the products that we are building are channel agnostic. That is, they have the interoperability across different channels and have got seamless integration across omni-channel initiatives. The last step in the process is to build effective monitoring framework and deploy that so that we are able to identify any kind of irregularities in a real-time automated fashion and fix them instantaneously. Productizing data science has got many benefits. It helps the organization move up the data science and analytics value chain, and it is enabled through data democratization. So what is data democratization? It's a process of providing the right data and making that available to the right audience at the right time through the right platforms. Data democratization helps in achieving data science productization, which ultimately helps in insights democratization, leading to enterprise scale value generation. Productization of data science helps the organization move up the data science and analytics value chain. It helps the organization automate and scale business processes. It helps the organization utilize its scarce data science resources to do the niche data science work, thereby freeing them up from the mundane, repetitive task, keeping them excited with the work that they enjoy the most. This also helps in achieving human capital efficiency because it reduces all kind of a manual effort. Most of the work and tasks are taken care by the algorithm themselves, and human beings are allowed to intervene only as and when required. This helps us to do a lot of research as it gives us spare time to do experimentation, research, and fosters innovation within the organization. For organizations like Walmart, which have got presence across different geographies and operates across different channels, productizing data science can help bring in additional benefits like tech capability standardization. It also helps us putting effective governance framework in place to ensure data governance, model governance, to ensure the reproducibility and interpretability of the models, to ensure we have effective and ethical AI framework deployed across the globe and across all the channels. Let's take an example of one of the use cases that's been deployed at Walmart, which is symbolizing productizing data science as well as driving enterprise scale value. If you look at this graph, the top graph, you'll realize that there was a business use case, and business approached us primarily because we were seeing that there were 73% of our customers who came to our site who were dropping off the site before they completed the next step of the cart build out. And this had negative repercussions, specifically on the overall conversion. So we wanted to identify what is happening in the top part of the customer journey, as we are seeing that there was a leakage that was happening in the top part of the customer journey and customer funnel. After doing some exploratory analysis, we found out that one of the major friction points that our customers are experiencing is around identifying the right products and searching and getting the right products that they are wanting to buy. So product discoverability was an issue. So we came up with graphical probabilistic models. We used bipartite clustering algorithms to define effective taxonomy on our site. This helped improve the overall search results through faceted search and ultimately resulted in better add to cart, leading to the better overall conversion. As you can see here in this graph, by deploying this solution, we are able to see that the overall sales spiked up as compared to the other control categories. And we were able to see incremental lift because the actual sales were more than that of the predicted sales as compared to the other untreated categories. After seeing that this is having a positive impact, we deployed the solution in the production environment, and we are able to deploy that across the enterprise through a core platform called as Tango. Now, the site merchants have the automated taxonomy recommendations available to them, and they have to just use a click to either accept or reject these recommendations. While deploying this across 5 different categories in the proof of concept stage, we are able to realize around incremental development and incremental revenue of around $64 million. And scaling this across the enterprise helped us realize around $350 million of incremental revenue across online grocery and general merchandising. This is a classic example of how data science can enable value creation within the organization. Here is another use case around site content curation. As you can see here, Walmart spends millions of dollars in terms of creating these creative assets. And these assets are important because they symbolizes creative content, inspirational content, promotional content. While we spend a lot of dollars in creating these assets, we do not necessarily know what is the return on investment on these content. So we need to understand and answer some of the business questions around what content resonates the best with the customers, in which geography, and which content should be put on the site for what time frame, and how long should the content stay up on site. So to answer all of these questions, we use computer vision algorithms, which came up with the item asset tagging, curating the content from millions of combinations that are available across items as well as the assets. This helped reduce any kind of a manual intervention, as well as help improve our overall customer journey. On deploying these algorithms in the campaign, we are able to generate and realize around $18 million of incremental revenue just for one campaign. And we are scaling this across all the departments and categories, which has the potential to generate hundreds of millions of dollars of incremental revenue. This is another classic example of how data democratization has led to data science productization, which has ultimately led to driving enterprise scale value. Now, productizing data science is not only about generating benefits. There are quite a lot of risks associated with productizing data science as well. So we need to identify these risks and mitigate them early on in the life cycle to be able to generate enterprise scale value. Let's see what these risks are. The first risk is around concept drift. The predictions made by the static machine learning algorithms become less relevant and less accurate as time goes by, because machine learning algorithms are designed to get smarter over a period of time. But without the constant feed of the new data, they become less relevant and they deter in accuracy. And this happens pretty much when they are deployed in the production environment. One of the common mistakes that most people make in the industry is looking at these machine learning algorithms as any other kind of software products. In reality, they are not, and they need to be treated differently. Else, we'll run into this risk of project failures. The second risk is around losing resource investment. How many of you have worked on the projects that have succeeded 100% of the times? Well, in reality, that's not the case. For all practical reasons, some projects fail. And when they do so, the best case scenario is that you have invested only limited amount of time and built the proof of concept. And the worst case scenario is that you have built the entire product end to end, deployed them in the production environment, and the results are not accurate and they're not good enough. This leads to the organizational leadership losing that confidence in the data science teams and pulling out the resource investments. The third risk is around production system failures. Now, software industry has gotten much better over a period of time. However, expecting the software engineers to deploy the machine learning products or machine learning algorithms in the production environment without significant training and experience is like setting them up for failure. We need machine learning engineers to do this task. These machine learning engineers are the data scientists with a stronger software engineering background and can sometimes work very closely with the software engineers who build and maintain these production systems, lack of which may pose a major risk. Legal risks are bad because they can jeopardize the entire data science roadmap of the organization, can lead to severe brand and reputational damage, needless to say, legal implications. Evolving regulatory framework is also something that we need to be looking at, because regulatory framework pretty much dictates how the algorithms are built and deployed in the production environment. Some of the unintended consequences associated with productizing data science need to be looked at and need to be addressed early on in the life cycle and across the life cycle of data science productization. Some of these unintended consequences are hidden errors. Machine learning algorithms are the statistical representation of the world that we live in. They come up with some outcomes based on the curated data sets that's been presented to them. However, these data sets may have hidden errors. They come up with some sort of training based on the data set, the curated data sets that's been presented to them. When these hidden errors are accepted as a part of the training set, the outcomes or the outputs that the algorithms generate would also have hidden errors. We have seen many examples of chatbots unleash racist comments on the social media because there were such examples on the public display. By productionalizing such models, we may run into risk of amplifying the hidden errors. Institutionalization of bias is another very important concern that needs to be addressed. Most of the machine learning algorithms are interpretable. However, there are small sample of machine learning algorithms which still act as black box. And even the experts in the industry will not be able to interpret them very easily. Such lack of transparency raises concerns around unintended consequences, and deploying such models in the production environment would lead to amplification and institutionalization of bias. Filter bubble. When Ila Parisa came up with this term filter bubble, he warned us of hyperpersonalization. He warned us that too much personalization can leave people in bubbles. And these bubbles are bad because they make us believe that we are getting a representative view of the world. But in reality, we are not. And we do not know that. There is a lot of excitement today as we build self-driving cars that actually work. As we build algorithms that can outsmart human beings in the spaces like gamification, which are very creative and which we once thought these algorithms would never be able to master. However, all of these algorithms can have unintended consequences. Let us leave aside the speculation of singularity today. What would happen if the algorithms that we as data scientists develop turn out to be discriminatory? Deploying such models in the production environment raises such concerns around unintended consequences and amplification of bias. Such concerns needs to be mitigated if we want to drive enterprise scale value. And how do we mitigate such concerns and risk? We can do that by focusing on these aspects. First one, model flexibility. A perfect model does not necessarily exist. However, a model should be flexible enough to have some real life consideration such that we don't have to do the entire architectural redesign for any new use cases. Computational efficiency. Computational efficiency may come second to the accuracy in the proof of concept stage. However, in the production environment, it's of utmost importance. I've seen many algorithms fail and many projects fail primarily because they have got poor runtime. Even the milliseconds matter in the production environment, and not focusing on that can lead to major risk of project failures. Focusing on tech stacks and data flows is also very important. One of the major aspects of software packaging is to connect the data flows in and out of the systems effectively. Because any deviation that's happening due to broken data feeds is very difficult to detect as compared to the outright application failures. Focusing on data science governance will also help us mitigate risk, as it will help us be compliant to regulatory norms around GDPR, CCPA, and HIPAA. So far, we looked at what is data science productization. We explored various benefits. We looked at risk and unintended consequences. We also spoke about mitigating these risks. Now, let us look at how do we create these data science solutions to drive enterprise scale value. What's the roadmap that we should be looking at? We need to be focusing primarily on looking at the financial rigor, bringing in the financial rigor within the ecosystem, looking at all the projects based on the impact that they're going to generate for the organization. We need to emphasize the cross-team collaboration aspect, primarily because these solutions and products are built with effective collaboration between tech, legal, and governance team. The solution should heavily focus on key interfaces and specifically focus on user experience aspects so that we ensure that we maintain trust, safety, and loyalty of our customers. We need to ensure that there is compliance, not just in the initial and end phase within the life cycle of these solutions, but across the life cycle to ensure that we are complying with the regulatory norms. We need to put in effective monitoring framework in place such that any model deviations can be detected in a real-time, automated fashion and can be fixed instantaneously. We are on the cusp of artificial intelligence revolution, which many people believe is the single largest technology revolution that our species has ever encountered. What kind of the outcomes will this technology revolution bring? Will we be able to predict these outcomes and shape our future? Well, we don't know. Will we be able to bias our future towards the positive outcomes and positive consequences away from the negative consequences to improve our longevity, end world hunger, and create capabilities to live in space? Well, we don't know. What we know for sure is by responsible, ethical, and structured way of developing and deploying these solutions and productizing data science in an ethical manner, we'll be able to drive enterprise scale value, which will be beneficial not just for our businesses, but for our community in large. Thank you.
Wow, Srujana, that was amazing. Thank you so much for sharing. If you could stop sharing your screen, I know the virtual audience wants to give you a huge virtual round of applause. Thank you again for taking time to share with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.